Hey, it's Paul, and today we'll be doing the second day's problem sets for Advent of Code. So, today's first part of the problem is that the elves are running low on paper and they need instruction set on how many wrapping paper they need. So they have three variables, which is the length, the width, and the height of a present. And the formula for finding the surface is pretty straightforward. Multiplying one two-dimensional surface, and since there are two such surfaces in a present, you multiply it by 2. So what we need to have is we need to find the square of each of wrapping paper overall in the input data. So I've already downloaded it in input data, and it's sort of in this format, which is the separator is X, and we can simply use some splitting instead of some regex for this task. So let's create a new file. And we've already got the data, I believe. Yes, we have the data, and we can start analyzing what we get with it. So in this example, we can see that when comparing to the previous example, when we had all the data in one line, show you that it's only the one line, it's the index of the line, so where you're just using one line for that. In this example, we use lines to separate each present dimension, and it goes quite a lot. So, I mean, that's 1,000 presents. So for that, it's pretty easy to directly read from the file descriptor, as in reading each line. And we can simply, by reading each line, we can already see what the surface is. Let's call it surface sum. So we start, of course, with 0, and we have a formula which is let me see, yeah, it's just twice the same, so we can earlier just define this formula to be more consistent with the code and not to put everything in one place. So get calculate surface. So it's width, height, no, it's length, width, and a height. And we simply return 2 times width plus width times h, height, and length times height. So simply what the function calculate surface needs is numbers, but what we read for each line is rather this string, which consists of numbers and x's. So we can quite simply split it into 3. I mean, it should work in a sense that we can say its length, width, and height, and then just take the line and split it by the symbol x. but then again it could be a problem of like some data being not ready, and we can just split it into one object which would be an array, and just assign the first three into length, width, and height accordingly. Right, so yeah, let's double check if it's the same. Yeah, it's length, width, and then height. Okay, so we already have them, but the thing is that each of them is not an integer. So we simply apply that L is integer of the first item, W is the integer of the second item, and finally the height is the integer of the third item. And simply enough, we just add everything to the sum of the surface. And it's not necessarily important to have the same variables as the parameters, but it's just a coincidence that it's just convenient to have them that way. And then let's print the result. Okay, so that's quite a lot, and let's check with the results. It says a different number, which means that we also will need to define something else, because I haven't read the problem fully, I'm sorry. So we also need extra paper for each present, the area of the smallest side, which means that for the function we have to find which of the sides are the smallest, which means that we can like define it in side 1 sides as L times W. So in this array we just get a lot of sides. I mean 3 of them. There's mostly in a cube there's 3 sides that have different surfaces, because the other 3 are just like their replications, so on the other side. So what we can do here is sum sides and then add the minimum of the sides. What sum does is it sums up all of the elements, and what minimum is just finds the minimum of these all values and uses it, returns it. So I believe this should work the way that I've intended. So yeah, it's the same number, so it's the answer. So going into the second part, we have a different problem, which is additionally we need to, every present looks better with a ribbon, and the ribbon is using the same width, heights and length, which sort of makes sense. And the finding how much ribbon we need for each present is the shortest distance around its sides, or the smallest parameter of any one face, which means that so we have ribbon just to get over the present. We also need a bow. Yeah, it's a bow. So the feet of ribbon required for the perfect bow is equal to the cubic feet of volume of the present. So it means that we find the volume, which is simply multiplying length times width times height. That's the bow, yeah. So we need to calculate the ribbon here. Let's start working on it. We can still have a look at the problem. Yeah, probably just open a new problem, save it as day 2.2, and yes, let's replicate the data. So smallest parameter, okay. Yeah, let's just use the same way that we used to retrieve the data, just to save some time. And let's define them. Okay, what was I thinking about? Oh yeah, so the ribbon, it's called just ribbon. Define the function which is calculate the ribbon. So we get 3 variables, and we do several calculations. So first of all, we have to see which of these, which parameter is parameter is the smallest. So we can define ourselves the parameter. So parameters, and the same way that we did previously, we just calculated by 2 times L plus W 2 times. Or we can do a small hack, I believe. It should work, I suppose. H and L plus H, and then 2 times. I'm sorry, I'm a bit familiar with parameters. I'm not so bad about it. Also do the ribbon is equal calculate. So we have a demo function for this, which actually doesn't sum anything, but we can define it, it just returns 0. So overall the ribbon doesn't get anything. It will just stay 0 the whole way, but we'll just see how we calculate the ribbons. And we can also print out the image for some of them, and probably just to have a line to see what's happening there. Okay, so no, that doesn't work the way I expected. So maybe there's a similar solution which actually works, but let's then keep it close for every of these cases. So what I wanted to do is simply do element-wise multiplication. In MATLAB it uses a simple star operator for doing that. I'm not sure about Python, but generally this works the same. It just looks a bit more crowded in a sense, and like replication of multiplications of 2. Or yes, I mean, there's another way. So in a way, we don't really care in the parameter, because multiplication by 2 doesn't change a lot. It changes nothing actually. We can find the minimum and then multiply it by 2. Parameter, that's called half parameters. Just not to confuse ourselves that we have the parameter already. So okay, so we need, let's call it ribbon is already the, so this is the bow is equal to volume of a present. Now we just need to find ribbon plus 2 times the minimum of the half parameters. What it does, it searches for the smallest value. It doesn't really matter if you multiply by the same number, in this case by 2, you get, the same, one number doesn't become bigger than the other. So what we want to have is, it's for positive numbers. It might just be a bit different with multiplying negative numbers by negative numbers to get like different sizes, because it goes into the other side of compared to 0. So what we get here is minimum perimeter, I'm sorry, to just minimum perimeter. Let's just check it. We can. Okay, and yeah, and we just return the ribbon. Okay, and this should work out. I believe that we can. We ask to do anything else, so we get the feet of ribbon. It doesn't really matter what kind of metric number it is. We just get the same amount of any calculations be done on it, so we get the same metric data, or I don't know, we get 3812909, so it's the same number. And this concludes the day 2. As you have seen, just for the summary, we simply used, I believe that there won't be a problem which doesn't have a data which we start reading from a text file. Then we apply some kind of string parsing for the line, and we use some kind of calculations for these data, for the data that we used. So every line is independent from another line, which means that the elements in that line don't have any kind of impact to other lines. So that's pretty simple. So we just use a simple function which calculates, in the first problem calculates the surface, in the second problem calculates the feet of ribbon that we need, and just like in the for cycle, we simply iterate through all the lines in the input data and get the results for ribbon or the surface accordingly to that part of the problem. So thank you for watching.